All right, so today we'll be focusing on this thing is not moving. Sorry. All right, so we'll be focusing on encapsulation data scope in our first lecture. And then we're going to look a little bit more on the API documentation in the second part of today's lecture. All right. Now, I don't know why this is giving me problems. All right. So, Java is built from not only the core components, but there are many predefined classes that can be used to solve problems. And what we discussed last week is that even though that exists and you can find more information about that in the API documentation, there are times that you need to write classes of your own to solve the problems that you're trying to work on. Now, there are some key things to write in classes in Java, and we're gonna just recap a few of them. One is that a class consists generally of two things, what we call attributes that are used to store data, and the methods that carry out operations on that data that an object stores. Now, both of these have what are called visibility modifiers, and these restrict or allow access to either the methods or the data, right, that are in each class. Now, only attributes and methods that are declared public can be accessed outside of a class. So let's say you are writing one class that uses another one. The class that uses the first one can only access both methods or attributes that are declared to be public. All right, and we'll see what that means in a moment. Now, recall a mutator method also is called a setter, and this you will see in last week's lecture. It's just a classification of the role of methods, and a mutator is one that modifies values in an object, and accessor is one that just tells you or returns to you values in an object. And then we have the special one called a constructor. Now, let us look a little bit more in detail on what is to be covered today. Now, what I just spoke about was covered already. All right, so that was just a recap. Sorry, excuse me. All right, so an important concept in object-oriented programming is what we call encapsulation. All right, whether it's an attribute or a variable or a method, these are collectively referred to as members of a class. So members can be either a function, which we call in this case a method, right, in OOP, or data members, right, which are things that hold data for each instance of that class, which is an object. Now, methods can be, can be invoked by using the dot operator. So if I have a class called ABC, and then I have a method called calculate, I can say abc.calculate, and that will invoke the calculate method, which I would have specified inside of class ABC. Now, the member operation is used to access member of the class, right? And at least the ones that are accessible. Now, if you don't have a method that allows you to access a member in the class, a data member, that is declared to be private, then it's not accessible from outside of the class, okay? But we'll talk a little bit more about that in a moment. All right, so we can take one of two views of an object, internal or the external view. The internal view has to do with the details of the variables and the methods of the classes that are defined in it. The external view is really the services that an object provides and how the object interacts with the rest of the system. One is to say that the internal view is the details and the external view is just what you're allowed to see from outside. Okay? If you think of a building, the internal view is going to be when you get inside and see all the partitions that are there in the rooms, and then the external view might be What is the building used for? Is it a government ministry? Is it a school? Yes. What are the things that are associated with it? And you are only seeing what is outside, right? Now, from the external view, an object is considered to be what is called an encapsulated entity. It only provides a set of services and it does not expose its internal representation, right, or how things are done. All right, and the services that an object provides are said to be an interface to that object, right? This can include the variables, but it's not a good practice. So we try not to do that. We usually make the interfaces through methods, right? So if you need access to a variable outside of the class, you write a method that allows access to that variable. Yes? Now, one object called a client may use another object for their services, and the client of an object may request its services. But importantly, encapsulation requires that the method that is using or requesting a service doesn't know how the service is being fulfilled. That detail is hidden, right? Now, it therefore means that any changes to the object state should be made by that object's methods. These are important principles that we have to adhere to for good design. So we should make it difficult, if not impossible, for our client to access an object's variables directly. Right, Barbados? Yes? You're still with me?
Yes.
All right? So an object should be what we call self-governing. It's just like the same reason why my Bajan friends are not able to just walk into the Prime Minister's office and speak to him at leisure, right? You're only able to do so after requesting a meeting through the secretary or the assistant or whoever it is in order to get access, right? So same thing, there's some kind of control that is exercised by a class that doesn't allow direct access to the data inside of it without the use of methods. And that is the concept of encapsulation. Now, an encapsulation object can be thought of then as what we call a black box, right? You know the concept of a black box, Keville?
Yes.
I'm not hearing you.
Yes.
Good. So a black box essentially just means that we don't know how the details of how something is accomplished. You just pass in some input and you get back what is expected to be the output. All right. So when the client invokes the interface methods, and then the client invokes interface methods, and the methods manage the instance data internally and doesn't show the details. Now, all that theory behind it, let us really look at how this is done in Java. All right? So with Java, you accomplish visibility, encapsulation through what we call visibility modifiers. And there are 3 of them. All right? Now, final is used to define constants. And that is not so important right now. Right? What we want to focus on are the 3: public, protected, and private. Now, the protected visibility modifier involves inheritance, and we take that as a separate topic later on in the course. Now, members of a class that are declared with public can be referenced from anywhere, which means that anywhere in your program you can invoke that method, right? Members of a class that are declared private can only be referenced from inside that class. So those members, though, that are not declared with a visibility modifier will have default visibility and can be referenced by any class in the same package, which is kind of what the protected does, right? It might be a bad idea, right? Generally, what we say, make it private unless there's some good reason for it to be public or protected. And that's the principle for member data, yes? For methods, generally, those are public unless there's some reason to make them private, yes? So then, methods that provide object services are declared with public visibility, and they can be invoked by clients anywhere. Public methods are also called service methods, and pay attention to these specific classifications, because sometimes we might ask you to write a service method that does so and so, or write a support method that does so and so, right? So, or write an accessor, or write a mutator, yes, or write a constructor. So we will be using the terminology, because that's one of the objectives of the course, everybody, so that you will understand object-oriented terminologies, right, and be able to use them and know their applicability. Yes? All right, so public methods are also called service methods. Now, we have a special type of method called a support method, which is usually a private method, and it may be just one of those things that you want to use inside of a class and nowhere else, right? Let's say you're writing a class to do some calculations, right? And you might have a method that as part of the calculation, it calculates the tax to be applied, right? To some value, to a balance, right? Now, maybe there's nowhere else in the application that you want that taxable amount to be applied, right? And so that method is only useful inside the body of that class. And so you make it private. Now, another method in that class, which may be public, may call that method and use it as a helper function, for example, or as a utility function to carry out some part of a larger operation, right? And those methods are called support methods. Now, that method cannot be accessed by clients outside of the class, all right? So since a support method is not intended to be called by a client, it should not be declared with public visibility modifier. All right, so here's a quick picture which is worth 1,000 words. So these are the things that we're gonna be looking for when we're assessing you, for example, and we expect that you will achieve mastery over them. If you think about it, if variables are public, then they what? I'm not hearing from that side of the Caribbean. If variables are public, then they violate. Good. They violate encapsulation. If methods are public, they provide services to clients, right? Yes. If variables are private, they enforce. Right, they enforce encapsulation, and therefore you get a tick for that, right? Methods are private, they support other methods, and therefore they are not accessible from anywhere else. They are private business, right? Everybody happy? Great. So now that is encapsulation. Any questions? No, sir. Good. No. Yeah, I like when you talk to me. I want to know that you're still there, right? All right, so we're going to talk about scope. So encapsulation is about hiding information, right? Yes, and if you don't need to know, right, then you're not going to know. Right? There are some parts of my life that are private, and there are some parts that are public, right? And the things that are public, you access them through my member methods. Yes? My member data is generally private, right? Unless there's a very good reason that forces me to make them public. Okay? Principle. Now we're going to talk about scope. Yes? Now, scope of data really speaks to the area in the program in which that data can be referenced or used. Please pay attention to this. It creates some nightmares for some people programming, right? Note, data that is declared at a class level can be referenced by all methods in the class. Yes? Data declared within a method can be used. What do you notice? Can be used what? Nobody talking now?
Only in the method.
Only in that method, yes? Very important to note. Now, the data declared within a method is called its local method, right? Please pay attention to these. Local data. Sorry. Now, a variable declared at the class level, such as balance from our account class, which we started within week 1, is called instance data. Now, each instance of an object has its own instance variable. Remember that, right? So if I create a class called account, and then I create 2 instances of account, my account and your account, right? Then whatever instance variables are in my account class are different from my account from your account. Yes? Remember, the class is a blueprint, just like a house. And from that blueprint, I can create many different houses or many different objects. Remember, we also said same thing with the house. Every house have different attributes because every house will be at a different address, may have a different color, right? And so on and so forth. Same thing with objects. Every object has different instance data, except in one case, which we'll talk about in a little while. Now, recall from the account class, each time an object is created, a new balance variable is created as well. Now, the object of a class share the method definitions, but its data is different. Yes? And it's because the data space is different. That's the only way 2 objects can have different states. So here's the example again. When we create 2 examples, 2 object variables of type account here, account and account. The first one is my account. The next one is your account, right? Notice your account have more money than my account, right? Yes, you have 200 and I have 100, right? Yes? So I create 2 instances of the account class. One called my account and one called your account. Yes? Everybody with me first so far? And we know what the new keyword does? Yes? So we depict the 2 account objects as follows. My account, right, has a reference to a variable of type account, and account has a variable called balance, and that is set to 100. And that's what this statement does. Yes? Yes? Yes, now, the second one, the second statement does this, right? So we realize that both of them have their own space and maintains their own value for their balance variable. Yes? So they have 2 different states. Now, the difference with local data or local variable, right, is that it can only be used within the scope that it is defined. Now, a variable that is declared in a method is local. It is only known within that method. What that essentially means, you see where that method starts right here and where it ends right here? The variables, right, that are declared here are only known there. Everybody with me?
Yes, sir.
So if I say int result here, it's referring to a different variable. It has nothing to do with this result in here. Well, it would be char anyway. My bad. Yes? Everybody see that?
Yes, sir.
So then, now, because, the other thing to note is that when you call a method or when you define a method, the variables that you pass in as the parameters are automatically local variables. They become available in the body of that. So that's the body from the start here to the end here. So notice we didn't have to recreate num1 or num2 or message. They are already known. It's like declaring them inside here. Yes? Now, sometimes inadvertently you create variables that are the same name as those existing in an outer scope. And that is what we call shadowing. Notice there's a word here. Notice that word? What that mean? It means that you weren't paying attention and you did it, right? Because it's not a good practice. That practice is called shadowing, right? Because it can be confusing. Again, the Java is going to treat them as two different variables, okay? Because in this case, the version of ID here ceases to exist outside of the scope, right? And mark, okay? Have to be careful though, right? Not to do that. Now, I just told you that parameters are local data, and that the formal parameters, which really are talking about in this case, what you're passing here, right? Those are what we consider the formal parameters are local. And then, so when the method finish executing, that's gone, okay? Now, just note the last point here, that as long as the instance of the class exists, the instance variables remain. Okay? So, let us look at what actually happens when a method is called. So, we are assuming that this method called calc, right, takes in 1, 2, 3 parameters, right? Yes? And it returns some value that we're going to put in CH. Okay? Now, automatically, in the body of our program, when we call this method with some data, what it does is to copy this value into this, copies this into this, yes? And then it copies 25 into num1. So automatically, these now have values that can be used inside the body of this method. Yes? Everybody fine? Easy stuff, right? So here's a quick check. Where is the instance data declared Barbados? Not here, man. You need to talk up.
In the other scope. In the outer scope.
In the outer scope.
In the outer scope? What is the scope of instance data?
Go back. The entire document?
No, it's to that specific instance.
It's to that specific instance.
Okay.
So if they were to like declare the class or some, I guess. Okay, here we go. At the class level.
All right, make sure you're keeping up.
Okay.
Paying attention. Yes? All right, so let's move on to static methods and variables. All right, third concept. These are small but very powerful concepts in OOP, and paying attention to them will save you some time sitting up and wondering where this error is coming from. All right. All right, so static methods and variables. So last week we talked a little bit about static classes that Java comes with, right? And really, the simple idea is that these are some classes that you don't have to create an instance of them in order to invoke their methods. All right. Now, for example, the methods in the math class are static, so we don't have to create no instance of the class by saying like math x equal new math, right? Right? Not required. Right? And I'm sure you're happy to hear that, right? Save us some work. Instead, we can just use a class name and invoke any method that is defined in that class. How do we know that a method has been defined in the class? by searching for it in the API documentation, which will become your best friend as a Java programmer, Kevil. Our students here already know that that is the case because they were here last week. But you will catch up, no worries. Right? So in this case, I can just write the name of the class, right, which is math, right, dot sqrt, and because I know what this does already, I can tell you that this calculates the square root of any integer that I pass in here. Yes? And it returns me that value. Everybody sees that? So what does a static class member allow me is really to access that method without, or access the services without having to create an instance of that class. Okay? Variables actually can be static. And that's what we're going to move on to now. All right? So we declare static methods and variables using the static modifier. That's the keyword static. It associates the method or variable with a class rather than with the object of that class. Now, notice anything that is declared as static, right, are often called class variables or class methods. You know why that is so? Because those are going to be shared by all of the objects of that class. And we'll see now. So here's an example. So we have a class called helper, and we have a method here defined with the public visibility modifier, and it's also declared as being static. It returns an integer, and it's called cube. It takes in an integer called num. Everybody see me so far?
Yes.
Good. And all it does is multiply num by itself, right? And it returns that value. Yes? So whatever it returns is connected to that. So we have to make sure that the result of this is an integer, or else we'll have a problem. Yes? Yes. So whatever is being returned must also be the same as the return type. I don't write so well, that's why I type, you know. So because it is declared as a static method, the cube method can be invoked through the class name, just like how I showed you with math a while ago. So I can write just helper.cube and pass in a variable here. Okay? That now removes the need for me to say helper x, for example, equal new helper, and then say x.cube. Right? So it removes that. Right? Now, you have to decide when it's appropriate to use each one, but we're going to give you some suggestions a little bit later. Yes? So normally, each object has its own data space, but if a variable is declared as static, only one copy of that variable exists. So notice if we write private static float price, every time we create an object, the value in price is going to be the same. And any object of that class that is created, price is going to be reflected as the same. And in any of the objects, if you update price, every other object gonna see the same update. Right? So the memory space for a static variable is created when the class is first referenced. Yes? Objects instantiated from the class share its static variable. So, Barbados, just to give you a little rundown, yes? If I have a class called ABC, right? And I create a variable V, yes? What I would have created there is an object reference V to an object type ABC. See that? Good. In order to instantiate it now, I would have to say V equal new ABC. And open and close my bracket there, right? See that? So one is a reference to a class, which is this one up at the top. And this, in the second line, is the instantiation. So we're saying the memory space for a static variable is created when the class is first referenced, which is the first line. Now, every object instantiated from the class shares its static variable. Okay? Changing the value of a static variable in one object changes it for all other objects. So, the order of modifiers can be interchanged, but by convention, visibility modifiers come first. What that really means is that you could put the name before the modifier or the modifier before the name, but generally we put the modifiers first. Okay? So, remember in our first example, the main method is static. It is invoked by the Java interpreter without creating an object, right? And it has to be, yes, or else your program won't work. Now, note that static methods cannot reference instance variables because instance variables don't exist until an object exists. So if in my class I have static variables and instance variables, only the static variables can be accessed before I create an object of that class. Because object variables or instance variables depend on an instance. Static variables do not. Yes? Because static variables are class variables, while non-static variables are object variables or instance variables. So one only exists when instances are created, right? Now, static method can reference static variables or local variables. Okay? What that therefore means that if we have a static method, that inside the body of that static method, it has some variables. Those are local variables. Yes? And it can only reference static variables. Okay? We have an example. Generally, static methods and static variables work together. You try not to mix them too much. Right? So here's an example, one called slogan counter and one called slogan. So here is a class that is called slogan, which actually creates two variables. One is a string, which is private, called phrase, yes? And the other one is a static int, right, called count, yes? So every reference to it will change its value. Now notice our constructor. This is our constructor, and a constructor is a special method that instantiates a class, a object, Barbados. Now, inside this method, two things we do. We take whatever is passed in as str and copy it into phrase. Notice phrase is an instance variable. Everybody sees that? But count is a static variable or a class variable, okay? So count is incremented whenever a new slogan is created, because when I say, for example, just for argument's sake, if I say slogan P, right, equal new slogan for argument's sake, and I pass in a string no, right? It copies this string, because this string here gets copied into this based on the previous slides, right? So whatever is in str gets copied into this, and what happens next? It just adds one to count. Now, at the time when I created the object reference, count would have been created and set to 0. So when I now instantiate, right, which is to call this method, because that's what this instantiation is doing, it calls that method. Part of the execution of that method is to add 1 to the previous value of count. Everybody sees that? Now we have two other methods, the toString method and the getCount, which both of them just returns the value in the variables. As you would see here, this returns phrase, which is the value in the instance variable, and this returns count, which is the value in the static variable. Now, notice the program that follows, we're going to create a set of slogan objects, and then we're going to invoke the getCount method. So, here we create, notice this is just a Java class with the public static void main, right? So we create a slogan called obj, right? Object. And then we say object equal new slogan, remember the Alamo, right? And then if we print this out, it's going to print out whatever is in, remember the Alamo. Now, of note, when this statement is invoked, whatever object is inside here, it automatically looks for what is called a toString method. Now notice we had written a toString method in here. Yes? Which is a part of the slogan class. Yes? So the toString method is a part of the slogan class. So when we call the system.out.println, it looks for the toString method that is associated with that particular object type and uses that to print it out. All right? If it's not, then it uses the default. There's a default toString. I will talk a little bit more about what that means later. Now, here we create now another slogan, right? Which is, don't worry, be happy. Well, did we actually? Or did we use the same name? What happened there? Then we create another one, live free or die. The other one, talk is cheap, right ones run anywhere, and so on. Now, what do you think will be the value of getCount? Barbados, you want to guess?
1.
5. Why? Because every time we do new slogan, it is calling the method that is the constructor, which is this. See that? Now, the constructor has this line that says count plus plus. So every time we instantiate a new object, right, it adds 1 to count. And we did that one time here, second time there, third time there, fourth time there, fifth time there. See that? Yes? Yes or no?
Yes.
Want me to go that over? Didn't hear you. Anyway, notice here that we just said slogan.getCount. We didn't say object.getCount, you know, we said slogan.getCount. How is it we were able to do that? It is because our getCount method, yes, was declared as static. So we can just use the class name, right? And remember we said static methods only reference static variable. Remember we created a variable called count, which is static. Notice right here. And then we created a static method called getCount that returns the value of count. And so when we're ready to print out the value of count around here, we use the class name and the method. We didn't have to say obj.getCount. Okay? All right, so that actually concludes the first part of our lecture today. I'm gonna give you the opportunity to take a break, and we resume in 5 minutes. All right, so the second part of the lecture, we're gonna talk a little bit about method control flow, overloading, and I'll go a little bit more into the two-string method, which I spoke just briefly about a few minutes ago. The most important thing here is to kind of get a sense of what happens when we invoke a method, as we've been talking a lot about methods, and how our programs get executed, given that the whole idea is about message passing, and this occurs through methods invoking other methods and so on. All right. Generally, our program control is managed by our main method, which is usually written in what we generally term a driver class, right? But any object with a method can invoke any other object and their methods, right? So maybe one class is defined to support another class. Let's say we have a class that represents a student. Now a student could have an address, which is another class. And why an address would be another class, it might be that we want to represent address in terms of street number, lot number, city, country, and maybe a phone number. And then even phone number, we can have several different phone numbers. So we could represent that as a class also, and so on. Now, even name, we could have salutation, first name, last name, and middle name. All right? So we find that a class that may represent a student may be used in many other classes. So for example, in that situation where we want the student name, we would have to create a instance variable of type name. And then if we want the student name, we would have to have a method. Let's say name, first name. First name is the name of the object. Then we would have to now say first name dot get name. Yes? We'll talk a lot more about this. I'm just showing you that it's a reference to a class or an instance of a class need not be created only inside our driver class. Okay? All right, so to the main point now. So let's examine how methods work in more detail. So remember, a method declaration specifies a code that will execute when the method is invoked, or what we say when the method is called. All right. Now, once you call a method, the flow control is handed to that method, right? And whatever is in that method is actually done, and then execution is returned to the place where the method was called from, and it continues after that. All right. Some methods don't return a value. Some do return a value. And that is significant. We'll talk about that in a moment. So let's say I have some method called compute, and inside that method I call another method called my method. Notice what happens. My method automatically looks up where the details of my method is written, execute the code that is associated with my method, and when it's done, it continues back inside of compute where my method was called from and continues. Kind of straightforward, right? Wouldn't be any other way. It gets a little bit more complex than that, right? Because if, for example, I have a main that creates an instance of some object, obj, and then in obj we invoke doIt, then doIt invokes a method called help me, right? Then it has to travel, right, along those lines, finish doing what it was doing in help me, then it continues inside doIt, and only when doIt is finished, it returns to where it was inside main and continues. Clear, right? So you would imagine that depending on how many methods are called or invoked, the return to main might take a longer time. It might travel down a path because doIt could call help me and help me calls help her and help her call help she, right? And so on and so forth. And all of that keeps happening. And only when each of them finishes, it goes back to where that call came from and continues in that line. Yes? Now, execution of a method stops when there's no more code to execute or when a return statement is executed. And please pay attention to this. Okay? Now, I'm going to give you a quick example. If I'm writing some code, right? Just for argument's sake, I'm just going to try and write some code here. If I say P is equal to 5 and C is equal to 10. Yes? And then I say return P. And then A is equal to C times P. What is the value of A? Barbados. After I execute all those statements.
A is undefined.
A has no value. A has no value?
It's undefined.
Or undefined?
A has no value? How come?
Because you have to return. You have to return to it as is. It doesn't continue on.
I'm not hearing you well, but I think you're on the right path. Because anything that comes after the return statement is unreachable code. So
Correct,
this
yeah.
will never be executed. Yes?
Correct, yeah.
So you're wasting your time writing something after the return statement. Okay? Now, so it turns out that if you're actually modifying instance variables, right, you have a choice. And neither of them actually produces any change. Sorry, neither of them actually requires writing more code, right? There's one way is to just update your variable. So here's a method called withdraw, and here's one called getBalance. Okay? Withdraw updates the balance by taking away an amount from the balance and updating it. Now, we're assuming that balance is an instance variable. No, that's automatic. Now look at this code, getBalance, where it returns balance minus spending, or return the value of balance here. Now we're basically doing similar things, the same thing, right? But in one case, we use a return statement. The other case, what we just do is update the variable. It's a matter of design, okay? Some people prefer to return a value, some people prefer not. Yeah? I just told you also that when you return, after that, anything that is after that doesn't get executed. But also note that when you have a return statement, a variable will become available when that function has ended, when that method has been executed. Okay? Now, you have to make sure that whatever the variable type here after the return statement, that the method is set to have that return type. And we're going to look on it again. So the return type is the value that the method sends back to the calling location. The method does not, if the method don't return a value, then the return type is void. All right? And I told you that already. So some examples of return statements, they can be expressions like this. They can be new instances of variables or some value that is being taken out of a instance of a class. So get balance, remember get balance returns me the value in the balance after taking away an amount, right? And so what we end up doing here is creating a new instance of account which had $200, and then we apply get balance to that. Okay? Now, another way you can actually return an object is to say return new, and then you write the name of the class, and then you pass in the variables that you want to use. Yes. So if this method is supposed to update something, then you update and return an instance there. That could be one reason. Any questions?
No. Nope. Very good.
Everybody happy? Great. All right. So that's control flow, right? And so you can always follow the control flow of your program based on which method invokes what, and when each one is finished, you know it will go back to the one that first invoked it and continue from there. All right. Now, one of the beauties of object-oriented programming is the ability to have two methods with the same name, right? But defined to do things a little bit different. Okay? And now, the good thing with Java is that automatically Java knows which one to use depending on certain things. Yes? Watch what we're talking about. So this concept of method overloading is a process of giving a method the name, multiple definitions, single method name, multiple definitions in a class. All right? So each definition can carry out a different operation or the same operation in a different way. So if a method is overloaded, the name is not sufficient to determine which method is being called. Notice the word not is there. Okay? The signature, pay attention to this, of each overloaded method must be unique. What is included in the signature? The number of, the type, and the order of the parameters. So another way of saying is this is the amount of the parameters, the type of the parameters, and the order. So basically, if you have int, float, sorry, right? It's different from float, int. That's order, okay? So the compiler determines which method is being invoked by analyzing the parameters. So notice I have one method here called tryMe, which takes in an integer called x, and I have another method here called tryMe, but this method takes in an integer x and a float y. So if I call tryMe over here with two parameters, an integer and a float, the compiler automatically knows that this is the one to invoke. You don't have to tell it. Yes? Good. Now, notice they do two completely different things. Yes? It's like if you go to the bank, for example, and you're setting up certain type of account, they might say, or if you're getting a mortgage, they might say, okay, people who have an account with the bank for over 5 years get 5% mortgage. But if you don't have an account with the bank, then you pay the full rate, which is 7%. Yes? So in this case, your setup mortgage rate would either have just your ID number or your ID number and the amount of years that you're there. And if you weren't a customer before, then you know the version of the method that is going to be called is the one which only has your ID. And if you are an account holder, then it's a version of your ID and also the number of years. Yes, and the programmer will write both, but wherever that instance or object is used, he doesn't have to worry about having to focus on which one he's using, right? He focuses on which parameters he has, and the Java will invoke the right method. Yes, isn't that nice? Of note, the return type of the method is not a part of the signature. And I hope you're paying attention to this one, because I'm gonna ask you a question in a moment. So the overloaded methods cannot differ only by their return type. All right? And just as a note, the thing you'll overload the most is constructors. Most times, you have more than one constructors in a class. Now, even if you don't define a constructor, basically a default constructor is created in Java. All right? So if you don't write a constructor, there's a default constructor which sets all our variables to their default value, which means that all numeric types are set to 0 and all other types are set to null, right? Now, so notice something. These methods all have the same name but different signature, right? So notice this has num1, num2, and message, right? Which is an integer, and a string. This has only num1 and num2. This has num1 and a string. All of them have the same name and return type. But notice that this one is exactly the same as that one, even though one has a return type char and one has a return type string. Why? Because I just told you that the return type is not enough to make them different. Yes? What needs to be in place to make them different is the number of parameters, the order in which the parameters appear, right? And the parameter types. Okay? So if you had double here, right, it would make the parameter type different because all the others are int, and that would be fine too. Okay? Now, the reason why print line actually works, whichever variable you pass into it, is because it has what is called a toString method that is overloaded. And how it's overloaded? If you look in the API documentation, you will notice there is a method, println, that takes in a string, one that takes in an integer, one that takes in a double, among others, right? So that once you write system dot out dot println, whatever you pass in here, right? Whatever object type you pass in here, it will look for the matching version of println based on the parameter you pass in, and it will invoke that one. Yes? Now, we're gonna look a little bit on the toString method, which is what is actually called here, right? And in that case, if you have a toString method, then it's always going to be a string that is in here. Yes, but you would have noted from previous lectures that we could say int x equal 5, and then we could do a print line x. And x is a primitive type, it will print it out. Yes? Now, just as an example, the lines below here, this invokes the version of println which accepts a string. This one invokes a version of print line which accepts a variable that is non-string. So if total was a float or a double or an int, it would invoke that version of it. Yes. Now, the most frequent use of overloading, I said earlier, is with constructors. And there can be several constructors for any one class, but each of them must have a different signature. And what defines the signature? The number, the order, and the type of the parameters, right? And just two examples are there, which you would have been familiar with before. And I told you already that each class has a default constructor, and that default constructor initializes the object's data to their default values. So any reference type data is null, Boolean are set to false, and numeric data are set to 0. All right. So a constructor does not accept parameters. That does not accept parameters, also referred to as a null constructor. If you have a constructor defined, right, then there's no way to invoke the default constructor. Right? You would have to now create a null constructor on your own. Right? Any questions? All right, so moving on to the toString method, right? Now, every class has a toString method. I'll explain this a little bit more when we talk about inheritance, right? By default, this method returns the object's reference. That is the address in memory where the object exists, right? You can define how toString works for the class you write by writing your own version. And that is generally suggested. Right, that every class you write a toString method, all right? Because you want to be able to show the object in a particular way. Now, it is called automatically when an object is concatenated to a string or when it is passed to the printline method, which is the example I just gave, right? And it's a good way of debugging. If you are writing your program and every class has a toString method and something is going wrong, you might want to use the toString to print out the state of that object at the time when something is going wrong, and it helps you to debug to see if something has gone wrong at one point or the other. Now, here's an example of the use of the toString method. For example, with a wrapper class, integer, where we might have an integer type, which is face value, and we can invoke the toString method on the integer class, which is a static wrapper class, and it converts the integer to a string and passes it into the string called result. Now, that look a little convoluted. You could do the same thing by just using the double quotes here, right here, with a plus and the name of the variable, right? Does the same thing as what is done up here, right? Which is to take an integer, call a toString on it using the integer class, right? Which converts this to a string and puts it in a variable called string, which is a reference to a string object, and then it returns that result. You could do the same thing doing that, yes? Because this is a special way of creating a string object, and then you concatenate face value to a string object, which converts this to a string. So basically, all you get back is the string version of face value concatenated with an empty string. Yes? Same thing. Now, here we have a toString method that does some fancy stuff. Right, Barbados? So, here's the trick. When you create a class with a number of instance variables, right, or maybe static variables, right, maybe the way you want that data to be printed out is a little bit fancy. Let's say you have the name, first name, last name, and so on and so forth. The toString method by default is just going to print it out on the screen, line out, not formatted. When you write your own toString method, then you have the ability to format the printout. So for example, you see we did a little formatting here, like a new line. Yes? So in this case, we start with an empty string. We concatenate to that the last name, then the first name, then we go to a new line, and then we check if the location is empty. If that is empty, right, then we do some, and then we return that concatenated string, which is result. So when I actually call p.toString, Listen, man. When I actually say P dot toString, I get a nicely formatted output. It's not writing properly today. Sorry. All right? Instead of if I don't have a toString, right, and it just shows everything. Now, Kevin, I want you to realize this. If I have, for example, an instance variable up here called string secret, yes? And this secret is something that I never want to be printed out. But secret is useful for me in doing something in my application. Yes? Let's say it might be in encrypting the person information, my secret key that I use to encrypt. Yes? If I don't define my toString inside my class here, when I print out P, which is the person, yes, it is going to print out all of the instance variables that are located in that object. You with me, Barbados?
Yeah.
Now, if I create my version of toString, I can exclude secret so that down here, so all I'm printing out would be location and last name and first name. So that when I call system .out.println with P, it does not show my secret because the version of the toString that it invokes is the one that is defined in my class, right? Or so-called overloaded. You with me? So creating a toString also helps you to make sure that you format the object data in a way that you want it to be seen. You follow me again? So it's a way to also ensure that the presentation of your object is the way you want it to look. Yes? Instead of it just throwing everything in a string that is not formatted. All right? So one of the things you always want to do is to write a toString method. And notice how the toString method is written. We did not print out anything. Notice? What we did, we started an empty string, then we concatenate last name, first name, equals into a variable called result and return it. So basically, whenever we call system.out.println on P, for example, right, it invokes toString and toString produces a string representation of the formatted data from my object, and that's what gets shown. Yes? Kind of nice, yeah?
Sir,
Yes.
could you go back to the previous slide, please?
Go back through.
Previous slide with not the one after this.
Okay.
With the variable result where you calculated the get last name. Is that missing the brackets on the end since it's a method?
Yes, it is.
Okay.
So it actually should have brackets there.
Okay.
Yeah. Thank you for that.
No problem.
Any other questions?
No, please.
So just to note by convention, you never print out a value from toString. You always return a formatted version of what you want to be printed out. Yes? All right. I think that would be it for today. On